Well, thank you, everybody, and welcome back. I'm glad to see everybody returning. Rolf kind of helped serve this up a little bit. Some of the stuff Puneeth and I will be covering here regarding the Material Compatibility work stream for immersion cooling. And this is done within the immersion cooling work group. It's a subgroup that is helping to support the requirements documents. And I'm happy to have Puneeth join me here today. He is one of the co-leads with me on this project. He and I are working together on it as leads. And Puneeth recently joined the project. What about?
From August.
Yeah, from August. And he has certainly hit the ground running and has really done a great job filling some really big shoes of his co-lead before him, Eduardo Alvizedo, right?
Yes.
Yes. Yeah. So I just want to give him a shout out. And I also want to give a shout out to Jamil Shaw, who was also a previous co-lead, who has rejoined the group now and is helping support us. So we've had a lot of folks involved in this from helping guide this project through. So I'm not going to spend a whole lot of time on this because I'll just be speaking redundantly to things that Puneeth and I will be covering. We have a flow here that we'll be talking briefly about the compatibility matrix as a snapshot. We'll also talk about some of the criteria for the material compatibility, the one approach proposed that we're working on. How do you assess yes, no, maybe kind of decision? Test methods for the aging test of single-phase fluids, required liquid specifications, the minimum dielectric requirements for a fluid. Certainly, we would expect any fluid that's going into this environment would have some minimum requirements that we'd want to make sure that we cover the suitability for use. And then a new topic we'll be jumping into with some level of discussion would be the signal integrity specifications. And this by no way is really a new topic. Yeah. Because certainly signal integrity has been something we all been thinking about. But in terms of the materials compatibility, this is something that we decided to take under that activity and start thinking about the signal integrity and some of the tests that might be necessary to help support people developing and building the servers. And with that, I'm going to hand it over to you for the next couple, okay?
Okay, thank you, John. Good morning, everyone. So this slide is actually, so as part of the committee, we are actually asked every fluid supplier in the market to come forward and do some material compatibility testing for different ID components. This is just a snapshot, but there is a list of more than 100 different type of IT components being tested by each of these individual players involving synthetic esters, natural esters, synthetic hydrocarbon, and then GTL, and then you also have two-phase fluids as well. So all these manufacturers have contributed for this spreadsheet. This is only to give an indication when somebody is coming new and trying to understand whether this fluid works for a specific application involving different IT components. Then this is in a public domain. People can go there and actually look for more information about whether it is acceptable, not acceptable for each of these IT components has been listed. So going further, so we have compiled all the information that was gathered from all these suppliers. And as I just mentioned, there are 4 or 5 different types of fluid types that is available for immersion coolants. And what percentage of information has been shared for each of these players. I think, so that's what it is actually shown. So there are still more to be added. So we are trying our level best, but we are also making sure that we have given enough time for these fluid manufacturers to do testing and add these information to the spreadsheet. We are expected by end of this year, we will have this robust spreadsheet completed, and we are planning to do publishing this online. So once we had information added to the spreadsheet, I think the next thing that committee was discussing is about just mentioning acceptable, unacceptable, or case by case. What's the metric involved in this to make this decision? And we had a detailed conversation with involving fluid suppliers, ID component manufacturers, and then system integrators as well, so that they give their voice to what we tried to achieve through this committee. And one of the suggestions made was we actually list several test methods or we call it different test properties. That is very, very important for us to understand when we are actually doing the compatibility testing. And there are there is quite a bit of list that has been listed there. It involves volume change, mass change, shore hardness of the material, color of the fluid when it is actually being aged in a sample at, let's say, for example, at 80 degrees C for 2 weeks, 4 weeks, and 6 weeks, what happens to the fluid. If there is any polymers, if it is actually releasing plasticizers into the fluid, then there is actually change in color as well. So all the parameters have been captured, involving also on the thermal properties as well with DDF, dissipation factor, acid value, and then color of the material as well. And
Okay.
yeah, sorry.
So to Puneet's point, we decided to take a fairly simplified guidance approach, a red light, yellow light, green light, that it's acceptable, that you need to look at it case by case, and it's probably not acceptable. So we wanted to keep this simple right now for 2 reasons. Number one, even though we have the 6 different basic categories of fluids, there's all kinds of formulations within each one of those fluids. So everything needs to be taken with a bit of a grain of salt, because the specific fluid with any given category will be slightly different and maybe significantly different than a cousin within that same fluid.
Yeah.
And then similarly, some of the materials, all of the materials within the server, they are not all of identical formulation either. So we took a rather generic high-level approach to this, and because we took that rather generic high-level approach, we thought it would be inappropriate to dive too detailed assessment within this matrix and maybe mislead people. So we said we're going to do this green, yellow, red light. And similar to a traffic light, just because it's a green light, it doesn't mean, for example, you could be approaching a green light, but an emergency vehicle is coming through the intersection, so you don't go. Just because this says acceptable, there could be something really unique that you need to be aware of and think twice about, is it really acceptable in all cases and what you're specifically doing? Case by case, I think that's pretty self-explanatory, that there's been the observation of a meaningful change in properties, but to the best judgment of the group, we don't feel that they degrade the usability of the 2 materials together. And then certainly unacceptable, it's a significant change that in a lot of cases we believe that it may be a use case situation. But that doesn't necessarily mean that a different formulation within that group with a different formulation of a similar material of the server would yield the exact same result. So unfortunately, like many things in life, it depends. But this matrix that Puneet spoke to, is going to give people the ability just to look at the range of different materials, kind of the general observations about it, give some guidance where you might want to dig just a little bit deeper, do a little bit harder due diligence, especially if it's in the case by case or unacceptable, to understand the implications there. And then again, just because it's said acceptable, you still may want to do some case by case there as well. But we settled on, for the acceptable, these key criteria, whether it be a volumetric change, a mass change, a shore hardness change, the color, the color is kind of, it is more of a perception thing. I don't think the color shift is anything meaningful, but we felt that, this is something that people may be curious about, so we thought that it should be something that is observed and considered. Certainly the breakdown voltage. If the materials don't behave well and you're seeing a significant change in breakdown voltage, the dielectric fluid probably isn't the right fluid for that material. So that's an important thing. The dielectric dissipation factor, interesting, it's kind of I guess it's a dimensionless number really. It's a ratio of the reactive capacitance by the resistance, and it gives you an idea of the insulative properties of that material. So that's an important one. And then again, we look at not only the fluid, but the materials as well to make sure that there's nothing funny on either side of that. So just because the fluid didn't do anything undesirable, but the materials still have to be validated as well. Let's see. So we decided to develop a little bit of guidance on trying to do a highly accelerated or aging test method for these materials. And this has been a lot of conversation between what numbers to put in here. At the end of the day, where we are right now is we've decided that 80 degrees C seems like a reasonably appropriate temperature, that you are exposing the fluids and materials to a fairly elevated temperature, but you're not necessarily going to a point where we know some materials are compromised, period. You know, there's some materials that around 82, 85 C could be problematic. So we decided 80 C, and there's an exemption there that if you know that the material has a problem less than 80 and you know you wouldn't ever use it below that, you can certainly consider it there as well. The duration is 14 days. At these elevated temperatures, the experience of all the guys, various contributors say, hey, if you're going to see something, you're going to see it in 14 days, and it's going to give you a good indicator there. And some of the properties that we're looking at is certainly the color that we mentioned, breakdown voltage, the DDF, acidic value, dimensions and weight and shore hardness as well. The fluid sample, right now we're using a 800 milliliter sample, and we're saying that the material that you're testing in the fluid needs to be 1% of that volume, regardless of the form factor of that material. There for a while we were thinking about trying to complicate it, depending on what the form factor of the material was. We were going to have two different levels, but we simplified that and said, you know what, that's maybe getting a little bit too much in the detail, and let's simplify that a little bit for folks doing the testing there. The sample handling process, you know, we certainly think it's got to be able to control to 80 degrees C, and we want plus or minus 1 degree C, so we have fairly good controls over the temperatures, that it's not meandering all over. And then the container itself, we're specifying that it be a glass container with a fitted aluminum lid over top of it. So these are just some of the high-level things, and Puneeth, fortunately, is going to dive much deeper into some of these now than I'm doing there.
Okay. So going much into further details about, you know, what are the other liquid specifications we are actually looking for. You know, as John mentioned about, you know, we have to test the dielectric strength of the fluid. And then we also need to test the relative permittivity value. For this, actually, you know, this is actually was a very good feedback we got from Intel for the signal integrity, what is actually people are looking for the chip manufacturer standpoint, and how much we should push forward to evaluate so that we are giving the most realistic testing for the fluids. And I think in the end, the committee actually came up with the suggestion of testing at 20 gigahertz, 40 gigahertz, and actually for test temperatures between 20 and 70 degrees C respectively. And then other properties we're actually looking at is also loss tangent value. Flash point is also very critical from the safety angle for data centers. Then we have auto ignition point. That is something that people are interested to look for. So pour points, all other properties that has been listed. So specific related test methods have been referenced so that, you know, everybody has to test if they're actually trying to meet the OCP immersion coolant requirements. Then these are the methods that has been listed. So we request each of you to look into these specifications and then report the results. So that is what basically the objective here. Going further, so I think since we are actually looking at fluid at different temperatures, so viscosity plays a key role. So we're actually looking at 0, 20, 40, and 60 C. And then acidity is actually one thing that we would like to see when the fluid is actually before it is immersed, and then after immersed for a certain period of time or maybe for lifetime. What's the behavior if there is any acidity is actually seen in the fluid when it is in an operation. Then I think one of the things that has been debated much more because these specifications we are looking at involving single and two-phase players. So one of the things that has been discussed much more in detail is about global warming potential. And finally, we have come to a conclusion that we just refer this test method so that, you know, we push this forward and, you know, report this information to people who are actually interested in. Yeah, so this is one of the key tables that we have come to this point with the help of a lot of people involved. So one is when the fluid actually before immersed, so we have some specifications listed. The key properties we are actually looking for is dielectric strength, resistivity value, flash point, auto ignition, sulfur content, and then acidity for different type of hydrocarbons we are referring here, plus the odor. Why these are important? Because this will actually give an indication of how the fluid is behaving when it is actually immersed. Now, this is a fresh sample. We run these use these tests for fresh samples. And then we also need to understand how the fluid is behaving in service as well. So if you say, the expected service life of a fluid is maybe between 3 and 5 years, then how the fluid will behave. And that is something that we have come to these numbers because this is based on the experience people have when they are actually done the extended study for fluid for different timelines and knowing what is the materials which are there in the market, how they have the minimum values. Based on that, we have kept these benchmarking.
Yeah, and I think it's important to keep in mind, if you look at that table that Puneeth was just sharing, you obviously quickly detect that not every attribute has a specific requirement to meet for the materials compatibility and ultimately in the Immersion's requirement document. But that list of other attributes is there to help guide people and understand the fluid and how it may behave and other considerations they may want to take into account before they decide to use these materials with these fluids. So we did not necessarily set a threshold for every specific attribute of a fluid, but we did give a very comprehensive list of the attributes that we believe that should be made available to the users that are developing the ITE, the folks developing the immersion cooling technology, and or the server technologist, and ultimately even the end customer. So I just wanted to explain, some people may realize, hey, a lot of these parameters didn't necessarily have a pass-fail criteria. That's because at this point, we don't believe it's appropriate to pass judgment just yet. I will also say that for certain, we know this is unsettled business. When we publish this thing at the end of the year, early next year, similar to the Immersion Requirements Rev 1 document, we know immediately we will be going and working through this to help advance the technology and the information to the industry as a whole. Because when you start at zero, it takes a little while. So maybe we're not in the running phase right now, and we're out of the crawling phase. So I think we're in the walking phase with this. But we've got a marathon ahead of us, so the challenge is hardly done. But as I was mentioning, and Puneeth touched on it, and even Rolf touched on it, and the reason it's been talked about so much is because there is this overlap between what's going on in materials compatibility and the Immersion requirements document. And certainly one of the things that was recently brought to our attention that maybe we should have a requirement, a need that folks producing the fluids publish this kind of information is signal integrity. So we've settled in with the help from a lot of folks out there on a couple of key metrics. One of them is the dielectric constant or the relative permittivity. And basically what this is looking at is it's looking at the permittivity of the dielectric material versus a vacuum, and comparing the two to one another and seeing how they stack up there. And at the end of the day, this speaks to the ability of this dielectric to maybe take on energy and release energy, much like a capacitor. So this is something that is really important to understand what it may be doing. You could imagine if you had a signal line out there and you started putting capacitors across it, it would kind of degrade the signal. So we want to certainly understand and make sure that people get this data published for them, that they can understand the implications for their use case there. And then the loss tangent, this is a little bit of an interesting one as well. Again, it's a dimensionless number. But I guess what it's looking at is it's looking at if you've got this electromagnetic energy on your signal traces, on your signal paths, and it's around this dielectric is interacting with this electromagnetic signal, and the dielectric may be sucking some of that energy and making it heat. So this is an important thing to understand as well, because ultimately this leads to signal loss as well. So these two things were deemed quite critical. One of the interesting things that we struggled with is a lot of the industry standards and knowledge base out there are really focused on transformer fluids. So not many transformers are working up in the gigahertz range on the AC power grids, obviously. So, we adopted for now that we do want to test at 20 gigahertz and 40 gigahertz and a couple of different temperatures as well. And I think we settled on 5 volts AC.
Yes.
Is what we settled on for the signal,
yes.
right?
Yeah.
To do these measurements.
Yeah.
So again, this is a maturing state of the art, and we're really optimistic and hopeful that as more people come in, we can start giving a little bit of guidance on some of these other parameters back to the acceptable, marginal, case by case, and unacceptable to say, hey, you know what, if you're in this area, you're probably going to deal very well with high-speed connections, no issue. But hey, if you're over here, you might think twice, is this the right combination of materials and fluids, et cetera? So again, very much a work in progress, a lot of effort. I mean, the collaboration of this is interesting because, all the fluid vendors coming to here, they've done a lot of investment.
Yeah.
All of the immersion cooling technologists have done a lot of investment. And the fact that we're actually talking and sharing and help bring this knowledge into a document that the industry can leverage is just a tremendous asset to everybody, I believe. So I want to close and see if there's any questions. I know we punted a couple of questions to this session, and if we didn't hit on them, maybe we can readdress those. I think we have a couple of minutes left, so if we've got a question there, we will see what we can do to respond to it.
Yeah.
I have a question regarding the sulfur and the ester contents, you posted a limit for the amount of sulfur and ester. So sulfur could be problematic, but what is the reasoning behind esters and hydrocarbons here?
So for sulfur, I think, at least from the fluids that we deal with for the GTL, so there is no sulfur in it because it's a material which is made of natural gas. But when you are actually dealing with synthetic hydrocarbons, if it is a crude derivative, you might see. But the reason why less than 10 ppm is listed here, because we need to have a test which can actually do the evaluation. If you are running a test which cannot detect that range, so I think that's why it was specified that keep it as less than 10 so that when you run a test based on the methods that we highlighted in the previous slide, so that it can actually give you an indication how much ppm levels we are actually seeing in the sulfur.
Yeah, and we did debate. There's some other test procedures that will get you down to 3% and even lower. But when we started looking around about the availability to do some of these testing in different labs, it got a little bit cumbersome.
Yeah.
And you can imagine if you say that you need to prove that you're less than 10, if your test is only good down to 10, that's probably not appropriate either. You probably need to have a test method that can actually go below 10 so you're comfortable that you're not right on the edge that you knew it was or was not 10. So you probably want to be at least able to test to 5 to say that, yes, I'm good and I wasn't at 10.
So what are the health effects, let's say, or effects on the hardware if you have somewhere around 20 ppm of sulfur?
Oh, I'm sorry. Yeah, so even at 20, I think I would like to take this question and respond to you if you'd send either Puneeth and I an email.
Yeah.
I do want to get the consensus of a broader audience. I don't want to speak off cuff and mislead anybody here. I believe that probably we formulated that that's not such a critical threshold at that level yet, but I do not want to mislead anybody, so I definitely would appreciate an email, and I think we had the call to action here, if you could go there,
Yes.
that you could send an email to Puneeth or myself, and we would certainly take that into the committee, discuss it with them, and make sure that we're all in alignment and give you a number that the whole group stands behind, rather than, oh, John Bean said at OCP. Okay? So I'm sorry to punt that, but I don't want to mislead.
So one last thing, I would request if anybody is interested to join the committee, so please send us an email so that we actually invite you so that more participants is actually welcoming for us so that we get more idea, more information, so that it gives a guidance to move forward.
Okay, and I think unfortunately we are running up against the wall on our time slot, and we're going to move on to the next presenters.